I'm going to do something a little bit, I guess, different. Um, just to let you know a little bit about me. It's so remote, so you don't have a perspective of me as an individual. So as we go through these slides, I'm just going to let you know this is who I am. This is what it means to me, and this is why these things are important to me. There's a bunch of different pictures that are going to be happening, and I don't know if you can hear that. It's a tractor going on right now. But that just I'm gonna just go through these slides real quick. So just a little bit about my family and who we are, and what life means to me. I have 7 kids, um, 5 boys, 2 girls, between the ages of 22 and 8, and just a little bit about um, where we stand right now. That's college, and then just all our family, life and family are important to me. Being with the kids and making sure that they're safe and sound. So, a little bit about my background. I am a middle child. That's me holding my beer from 21 beers or beers for Christmas or something like that. Um, so, I am a middle child. I have an older sister and a younger brother, and um, I have 42 cousins. My dad is the oldest, or was the oldest of 8, and my mom is the oldest of 6. Everything looks good in these pictures, and life looks okay, and everything looks good. But that's not my history, my background. I still have 10 cousins who are drug dealers, and still struggling with those things in their life, and still having a hard time. Just to let you know, I mean, I had a very hard childhood. This picture right here is my wife and I, and 4 of our boys. There are 3 Eagle Scouts, and one we just needs to finish his project, and he'll be an Eagle Scout as a freshman. So we're working very hard to not live that life that we had before, and change who we are, um, and just uh, get through this little bit of my career here. Past 20 years, been at Caterpillar for 12 years now. So um, just wanted to give you that as a background to help you understand who I am and what it means to me and what it means to be a part of this program that Todd and others have been such a great pivotal part to. Now I'm gonna go into the main part of my presentation, and that's me at Mapleton, Illinois. That's a 20-ton furnace. This is a 1-ton furnace pouring into ladle. That's a gentleman over there. That guy is huge. He's over 6 foot tall. He's in the orange jumpsuit. So that's how lets you know how far away that is. Um, um, oops, this is last year's date, but we'll get going with it. So what does it mean to fail? So actually, it is interesting that we have this conversation, this meeting today, because I had an intern and an ERD, which is a developmental, someone who just came out of college and is doing a rotation on program, just right here sitting at my desk, and we talked about failure today. And I told them, I fail here at Caterpillar every day. It's not about the failures. It's about what you do with that failure, right? You learn from it, you pick yourself up, you keep walking. And 3D printing is nothing but a great exercise in failure, right? Because it gives me an opportunity to create something very quickly, take it to the field, put it on. Oh, did it work? No, it did not work, right? So with that, this is the definition from Webster, um, just what it means to fail, and something that you should not do or expect to be expected to do, right? That's I think that's wrong. I told the 2 gentlemen sitting here this morning that I fail every day, and it's okay, because there was some hesitation in one of the conversations about whether they should answer or not. I'm like, just answer it the way it is. You won't have a true 100% of the whole story, so you just need to answer the best you can with what you have, and that might mean you'll fail. But keep going with that idea. Keep going with that. So for us here, an engine has hundreds of moving parts. I was on the head and block team for 10 years, and now I'm on the cooling and loop system team. And it means different things to different teams, right? So how they interact and how they use 3D printing. We have 6 low-tech 3D printers here. We have 2 very high-tech 3D printers here. I was at a foundry yesterday that they use 3D printing for metal. So they actually laser metal, uh, and it creates components that they use for aerospace and our components every once in a while, but also for a medical field. And so, and what we have in Illinois is a metal printer like that as well, and also have a sand printer. So we can do that at Caterpillar and create um, new opportunities for heads and blocks very quickly, and not have the expense of developing a new tool. And when I say expensive developing a new tool is in this economy $200,000 and 30 weeks in the time frame that we have right now. So instead of doing that, we can have an opportunity to create 3D printed parts and then get those to the foundry. You can use them as for managers and meetings, developmental meetings, for recognition. I have a plaque that I've created for our team members where we create a plaque and 3D print it and give it to them when they're leaving or retiring. There's a Pie Day plaque for when we celebrate Pie Day here at Caterpillar. Whoever makes the best pie gets the Pie Day plaque, and it is 3D printed, a giant slice of pie up on a stand. Um, so different things like that. And it's very easy. And Todd, shake your head if you can see my camera. These are some components. Thank you. These are some components where this is a C175 cylinder head, and this is one as well, but it's just shaved at an angle, right? So we take these opportunities to create these parts, and I can have this at my desk, and I can come to the intern and say, okay, yeah, this is where the push rod goes, and this is where the valves sit, and this is the exhaust port, and this is what I really want to focus on. This bolt pattern right back here. Those are the things I want to focus on. So it's very good for me to have as a visual aid or something that I can take to managers and say, this is what we're focusing on. This is importance, right? So prototypes, I have a better picture of it. This right here, this 3-piece component is a prototype that I printed May 20th. I created this for something we have here in the field, or not in the field, excuse me, something we have here in the shop as a failure in the field. This tube failed. Now we're going to create a new design on this tube and this new assembly. I took it out to the shop. I actually bolted this up, and it only took a day to print this off. With all the other jobs we had going on in the printer, I told the guy out in the shop, hey, the manufacturing engineer, I need this printed off really quickly. Can you do it? He set it up that night. The next day we came in, he pulled it off, cleaned it up for me, gave it to me. We walked straight out to the line. Does this fit? We put bolts through it. We tried to make a determination of whether I should use a 12-point bolt or internal hex bolt, and whether we would have enough clearance when we used a 12-point bolt or not, whether we could get that wrench on there, right? And so we had other designs where we had an angle, so it cut, swept back right there, or whether we came and went straight across like there, or whether we used the design I originally came up with, which was where we actually made just a scallop cut out. But that gives us the smallest part is only in the very middle section. That's 3 millimeters right there. And guess what? We created it. Here's the steel. Here are the components that we created based off of that 3D print. That 3D print took a day and was probably in wire, in the PVC wire. It was probably $1 at best, and maybe the engineer's time. We get paid a lot of money, so I'm not going to describe how much time it took him or what that cost. It's probably an hour. But this set right here took the supplier 2 weeks, and this cost me $1,000. So that's why we use prototypes, and that's why we use 3D printing, and why it's crucial and essential to our business. And that's just this. There's 3D sand printing, like I mentioned before at Mapleton. 3D sand printing is extraordinarily helpful to us because we can come up with new iron very quickly and put that out on the test bed and test right away with our new design. And instead of taking $20,000 in tooling or $200,000 in tooling and 20 to 30 weeks for development, we can go and do something in a day, take it and pour it in iron and have it finished and ready to go in a week and go drop it on and test it. That's why it's very critical for us to do 3D printing. Here's that component I was speaking about earlier. You can see that, change my pointer here. Here's the original design I came up with. Here's the 12-pointed bolt. Here's the internal hex bolt. Did I have clearance? Yeah, we had clearance. And then we could utilize this as our fit up test. And that gave our managers confidence that we could spend the $1,000 on these three pieces here. And they were okay. Yep, go spend it, move forward because it's a new design, something we've not done before. And so we got it quickly approved. We looked at this design to have more for more wrench clearance. We didn't need either one of those designs. These two cause more risk because this thinner wall is more exposed rather than just a little snippet of the arc. And so that's why we chose this design. But none of this would have been possible. I mentioned my history before, right? I mentioned I was born on the other side of the tracks, and that's where I was raised and had a hard life. None of that would have been possible if I wouldn't have had three great teachers in my life. Mr. Johnson, when I was in the fourth and fifth grade, I was diagnosed with dyslexia in the third grade, and I was going to a really nice school where a really good community, people took care of things, and it was really great. And then I had to go to a school that wasn't so great and very difficult and hard because that's where the help was. That's where I met Mr. Johnson and Mrs. Welch, so I could have help with my dyslexia. Mr. Johnson was a teacher that um, was very demanding, but also understood that I didn't have to be good at reading and still be good at math or use my hands. And so he emphasized those things for me. He kept saying, work with your hands. He kept saying, do the math, even though I couldn't read. And I had to have someone read the component or the math problems to me. Mrs. Welch taught me that even great people like Schwarzkopf and Benjamin Franklin can have dyslexia and overcome those things in their life and become great. And then in high school, I had Mrs. Brandstetter. I failed French, 2 semesters of French I failed. And she still took me on as an aide for my study hall because she knew that I needed something. And what I needed was someone that would stand up for me and take care of me and help me through that transition time in my life. And so that's what I think you teachers mean to students who need you. And that's why this program is important to me. And that's why I'm very happy to be a part of it and want to be success for Todd. And that would have never happened if I wouldn't have had those three great teachers and a great mother and father who helped try to take care of me and help me through the transition and the hard times of my life. They were difficult, they were hard, but everyone has difficult and hard times. So every kid that comes into your class is an opportunity for you to take on and make a great engineer, a scientist, and then Benjamin Franklin, Schwarzkopf. So to me, that emphasis on a teacher looking at a student and saying, hey, I got this great, awesome thing. I know you're not good at reading. I know you're not good at this, but hey, I think you'd be good at this. Your hands, you can do things with your hands. Let's go do that. My spatial relation was really great. Well, that's what 3D printing is. Taking a 2D idea, modeling it in 3D, and then creating it in the real world. Putting that into application as quickly as we can, as fast as we can, and then creating the actual components later on, right? And that if there was one thing to emphasize that people may not know about engineers at Caterpillar is we fail every day. We do the best with what we can. We will not have 100% of the answer, but we have to move forward with what we have. And that's why 3D printing helps us succeed because we can throw out a lot of guesses really quickly and put it into application as fast as we can, as cheaply as we can. And I think that's where this program and you teachers play a big part is to drive this importance to other students that this is important technology that we're going to be going to the future with. This is where it's used. It's used to save lives. Like I said, 3D metal printing. I actually looked, but horses are important. Not as important as people, but they're still important. Actually, 3D printing, we saw yesterday, a steel hip replacement for a pony, right? We also saw a heart that was done like this. This little girl could actually have the invasive surgery she needed because it was hard to see in the scans and the MRIs. And so they actually made a 3D printing of it. There was really interesting. There was metal like little cages, it looked like little sponges when we were there yesterday at the foundry. Those metal cages that were 3D printed were actually pieces that go into people's spines. And their spine grows around that metal cage because a vertebrae has been crushed or has had some problem. And so the doctor will put in this metal cage to help them fuse their back so they can continue to walk. Amazing stuff that we didn't have before. But that wouldn't have been possible if we didn't have 3D metal printing, because it's an intricate spider web, and we could never cast that. We can never cast something like that. So now we always, if you were a teacher of technology, you could say to your students, don't create something in a model that I can't create in real life. Now we're creating stuff in real life that we could have never created before, because I could not have a drill go in and cut that hole before. I could not have it sweep around and make those arcs with the machine processes that we have today. But 3D printing allows us to do that now and create this new innovative products for people that didn't have them before. And here's what happens, right? This was like a month's worth of work. Every one of these projects, and you know, they're all messed up, right? Well, these are other people's, but I have my own. Let's see if I have that presentation open. Yeah, maybe I didn't open that presentation, but there's failures where they look all fuzzy like this, or give someone some funny hair, or the 3D printer goes crazy. I have multiple projects like that. I used to have them on my desk until I moved into this new job, and I threw them away. But those are experiences. Those aren't failures, right? And people are quick to name and label and say, "Oh, that's a failure," but it wasn't a failure. It was a learning experience and an opportunity for me to grow as an individual and our entire team, because I use those as opportunities to talk to the intern that we had today, and the ERD, which is a rotational engineer that we had today, sitting at my desk, and me giving them advice on what we should do next with this problem or project. Any questions, comments, or concerns so far? Ask me anything. This is when we're in person, I can hand out the little toys and the trinkets and the fidget spinners that we created for everyone. But I don't have that here when we're virtual. But
You're doing great, Steve. And whenever I ask a question, it takes quite a while to get people to respond. So you're not doing anything wrong. And then at the end of our time, maybe more people will ask some questions.
So
oh, Amy's got her hand up.
Oh, okay, Amy, sorry. I can't hear that, Amy.
You're muted.
It shows that it's unmuted, but I still can't hear you.
We were having trouble hearing on our end, so I put in earbuds,
Okay.
which was the problem. Would you be available to do something like this by Zoom for a classroom to talk about 3D printing?
Yeah. I've done this before with Todd, so like you said, with Todd and Jeff at Ivy Tech, I wouldn't have a problem with doing it.
Thank you.
Jeff, you have your hand up?
Yeah, I just was wondering, how long have you been using 3D printing in industry like this?
3D sand printing. We unveiled that at Caterpillar to make cylinder heads. I was on the team for 10 years. Say 5 years ago is when we got into sand printing from cylinder heads. And tubes, thin wall tubes, double wall tubes. That was about maybe 5, 6, maybe 7 years ago. For us here in just making components like this, I think maybe a little bit longer than that. We've got our first LuzBot printer probably 7, 8 years ago, I think, when they first came out. We have a couple of them put in the facility here.
Yeah, you were showing some of those sand prints during our first round, and that was probably either 2016 or 2017, maybe. I don't know if you brought them the first year, but I'm pretty sure you did the second, which would have been summer of 2017.
Yeah.
And Mark asked a question about how does it work, the sand printing, and that'd be a good thing to kind of unpack a little bit. There's a resin involved, I believe, and a little bit about that. So
yeah, we have a video, and I actually have it, but I didn't bring it up. I should have apologized for that. But so the gist of it is there's a giant box, and there is a conveyor that drops sand down, and then it comes back and screeds the sand flat, and then they pipe a resin on in whatever shape you want. And then that resin sets, and that's one layer, and they keep it layer after layer after layer after layer. It's just like a giant cake with thousands of layers. Like, it's hard to see, but you might be able to see like the shiny layers on here. Well, that was plastic that was melted from a wire to a thin little wire, like a piping nozzle in a cake piper, and it was laid down. And that's the same way it's laid down. The resin is laid on top of the sand, and then the next layer of sand is put on and screeded flat, and then they do that again. And that's almost what it is for the metal 3D printing as well. They have powdered metal, and they screed it flat. The laser comes and hits that metal, powdered metal, melts it, and bonds it to the layer below it. And then it moves on. And then the next layer of powdered metal gets put on, and it bonds because the laser hits it and welds it to the rest of the layers below it. And that's how the sand printer works as well, is that you put that new layer of sand on, the resin hits that layer of sand, bonds it to the layer below, and so then it's adhered. So this next new layer where my hand is here is bonded to the layers below. You continue to build your cake up. I have a great video, and I apologize I didn't have
Well,
it going.
it's okay. You can share that later, and we can provide that to them if you have it like in a link, and we'll share it. They might not know, Steve. They might not know why you would use sand, and I think there's a really good reason for that, right? And you might unpack that just a little bit.
Yeah, let me go back to here. Okay, this is a C175 block. In your car is a cylinder block like this as well, a lot smaller. Okay, this is where the piston sits, the liner and the piston sit here, come up and down, and there's a cylinder head that sits on here. So all of these voids in here are where the sand was. So you create a form, it's a negative, right? So look at my hand. So if I wanted to create a 3D version of my hand, I wouldn't create my hand. What I would create would be all the geometry around my hand, right? And that would be sand. And I would pour the molten iron in, and it would fill my finger, right? So that's the same sort of concept here. So that's why you would use sand. It's the negative of what you want. And we have tools that can create that, like a pill. Like, think about your pills you get from the doctor, right? That pill was created because it was a bunch of powders of the chemicals and all the compounds that they want, and then they smashed it into that pill form and popped it out. And it's ibuprofen and it has a little number on it. Well, that was created because of that stamping operation. When we have sand, we have the tool, which is a form of a void, and I want to blow the sand in there, and I put resin in with it. It's ICBM, injection. I always forget. I always think of interballistic kind of missile, and I think ICBM, but it's injection molding. It's injection molding process. So they actually have the sand, and they actually pipe it in real quick with resin, and it sets. And they pipe a gas through it, and it sets in place, right? And so that's how the traditional way of doing it. The new way of doing it is laying it down layer by layer by layer. So that's why it's important to have that sand. Yeah, you're right, Todd. Those are actually at home. I took it to Boy Scouts, and I let the scouts look at them, and so I left them in the garage.
No, it's fine. So he's brought those in the past so that we could actually pick them up and look them over and things along that lines. But a little harder to do in a virtual setting. But that's great. Thanks.
Mark?
Thank you. I'm muted.
Amy, I can't hear what you're saying. You're muted.
Do you then, after you have the resin and the sand, do you put the molten metal on top and melt out that resin and leave? Is that how you get the metal mold, or is that a different process?
No, that's a different process.
Okay.
Sorry. Trying to pull it up really quickly.
I was going to say, Mark, as we printed molds to make fishing lures, they're kind of doing the similar thing, printing the molds for these engine blocks or pieces with sand, basically, instead of plastic.
That is right. That is exactly absolutely right, Jeff. So what you would print to make your fishing lure, that's what we would print as sand. But instead of pouring in the plastic for the lure, we actually pour in molten iron, and it creates that shape that we want, just like that fishing lure that you have. I apologize for not having it up. That's I have to bring that, Todd, next time. I can send it to you guys as a links as well, so you can watch it. I'll send it out this afternoon so you can see it. But it goes to the Mapleton pouring process and how we build it, and it's actually on YouTube, so there's no proprietary information there. But then it'll show you the 3D printing as well. Jeff, that's exactly right. You create what you want to see in the negative with the sand, and the thing that's difficult about a cylinder head is that there's all these holes inside here, all these little bitty intricate features that we want to create. So those are called cores. So all those holes get created by sand. So we have those cores in the middle, and we have the cope and drag, which are the boxes on the outside of the iron. So there's another glove of sand that sits out here, right, which creates the outer shell. And then there's cores that sit in the middle, which create the inner components. And then the iron gets poured into the head, and it runs and it pours into the head. It builds it up. Well, like I said before, that changing on the fly very quickly is really, really good to do with the 3D printing sand. And we don't have that same capability to move quickly, right? Caterpillar is a multi-billion-dollar company, and we move just as slow as a multi-billion-dollar company a lot of times, right? To get processed, to get people to sign off. But if I can do it quicker, cheaper, I have more leeway and latitude that I can go do those things really quickly and develop and discuss, and then advance the timing of the program and say, here, we got this thing already. Here's a cylinder head that's already created, and it only took me $5,000. Let's put it in the test instead of costing us $150,000 and taking weeks of time, right? So that's what we do. That's why we use Caterpillar. Caterpillar uses 3D printed sand. And because all the black areas here, like I did a cutaway of this cylinder block, all these black areas in this picture, that's where sand would be. Right? All these black areas in here, that's where sand would be. Any other questions or thoughts, comments?
Yeah, do you custom make your own software, or are you taking like Autodesk type stuff and rewriting code to make it fit for what you want, or are you just using typically off the shelf software and just using it to its applications or extents, or shall I say its limits?
Okay, so for our modeling, we use Creo or Pro E for Caterpillar. So all this was made, the models are made in the virtual realm with Creo, which is a version of Pro E. It's the newest version of Pro E. Okay, so we take that and we create a step file, and then we create a G code based off of that, and we use Cura, C-U-R-A, to create that G code. Then we put that in the G code in the LUSBot, and it prints it. So it's almost the same thing when you do sand and metal. They almost go through the same process. But there are a couple different formats that they use. So they don't use Cura. They use a couple other proprietary third-party softwares that they use to create that G code. And then we do the pouring of iron like we normally would. Does that answer your question, Mark?
Yeah, it does. I was wondering whether you used your own stuff, or whether you had custom stuff, or whether you used regular stuff that industry would use. So yeah.
We found that if we use what industry uses, it's a little bit easier to get support
Hmm.
instead of coming up with our own. So
Right.
we come up with our own designs a lot of times. We don't come up with our own software necessarily. We do have some special cases where we do have application software specific that we created.
What
But
do
in
I
general,
tell what do I tell a
go
kid
ahead.
that wants to work in industry doing 3D printing? Are there like apprenticeships that they can do, or is there a recommended educational pathway that you would recommend for them?
So let's say I'm not going to presume, but let's just say the kid is having a hard time, and like me, got D's and F's in high school, and his career path was going to go lead him to being in the military. And he met a girl, decided to change his mind and go to college. Ivy Tech has an MET program that trans um, that you can use to transition over to Purdue. So you get this associate's degree in MET, mechanical engineering technology, which is what I got my degree in from Purdue. And you can use that and leverage that over at Purdue. So you can take that work that Ivy Tech does, and they actually do a great job. I actually have two kids, one kid actually right now who's actually going to Ivy Tech, and he's taking classes in the MET program, and they offer a lot of opportunity. They actually this summer, I think I saw, Jeff, tell me if I'm wrong, they saw a bunch of free classes available to them, and they were doing a bunch of online classes for kids out of high school, or actually kids in high school. I think Jefferson High School here in Lafayette, the juniors and seniors. I know the seniors can go over and take Ivy Tech classes. So um, that would be something I would have, direct them to make sure that they could get on the right path. There's a multitude of ways to get to use 3D printers. You could go find it on your own, be determined, look it up, watch a bunch of YouTube videos, find someone who has a 3D printer that needs help or work, go work for them, or go through a more traditional path like state college or a private college or a university in that way. Now, one of the things that Caterpillar does offer, and it's not necessarily with 3D printing, but we have all kinds of. My mom sent me a text this morning. We were having a hiring, I don't know, extravaganza where they're going to try to hire several people to come in um, to help fill the line. If you become a technician and mechanic, you can be making six figures at Caterpillar in 1.5 to 2 years. We can't get people to travel for us and people to turn wrenches for us. It's a hard job, but you can make a good living, six figures without a college degree.
Wow.
Yeah. And actually, I saw Al Vans out of California. I was watching listening to Dirty Jobs podcast. Al Vans, they have welders they need. You could take a 2-year vocational training class learning how to weld, and you could be making six figures. And that's not just in California. We're talking about Midwest, yeah, or even over in the East Coast. You could be making six figures by being a good welder. The amount of money that I've spent wasted on a bad weld job here at Caterpillar is amazing and extraordinary, right? Because I'll pay for all the parts because, well, I put in the time, so the welder needs to get paid for their time, even though it was a failure, right? So if you have good welding skills or good aptitude skills, persistence, really. If you want to keep at it, keep at it, keep at it. That's one of the biggest things I advise all the young people that come in through our interns and rotational programs, and then my own kids, 7 kids, right? 5 boys, 2 girls from the ages of 22 down to 8. Never give up. You're going to fail. Yes. Get back up. Continue to go.
Wow. And I keep saying wow because I remember when I was uh I had a robotics club at Dover High back in 2012 or so. And my best kid, hands down, was a kid that was really not good at reading, but he was a gearhead. He wouldn't, you don't have to give him instructions. He kind of visualizes what he wants to do, takes and builds. And then he was our best performer, hands down. And all he wanted to do in life was to be a mechanic. And at an academic high school, say, well, you should do better. You should go to da, 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 da. And dude, do what you do, and you'll find your way.
Yep.
I remember him to this day. Best kid ever. Academically, though, I mean, he didn't have good grades because he just couldn't process information the way that we would expect him to.
Yeah. Right. Uh, uh, give you some background. I graduated from high school where there's 450 in the year that I graduated. My wife was the year ahead of me. She graduated ninth in class, and I graduated ninth from the bottom in class. I had D's and F's in high school. I couldn't pass algebra in high school. I had my algebra teacher tell me that I'll never amount to anything because I couldn't pass algebra in 11th grade. But there I was, sitting at IUPUI, taking Diffie Q's class that transferred over to Purdue, right? Because I never gave up. I continued to strive and continue to work. So
Makes all the difference in the world.
Yep. So continue to encourage and continue. It doesn't have to be the traditional kind of encouragement, like we were saying academically, right? It could be, hey, you know what? I know of Caterpillar, an awesome program that they have where you could become a technician and you could become a field repair technician and make a lot of good money doing what you love.
I'm writing it down. Thank you.
Yeah, you're welcome.
Anybody else? Anybody else have questions for Steve? Steve, one thing that we didn't unpack with this Trails 2.0, we had several speakers I know during 1.0 spoke about this. So there's a lot of the aerospace industry that are using 3D printing and the metals, the metal part of 3D printing. And we had somebody kind of come in, unpack a little bit about that. And I know you deal with the same kind of thing, that there's some advantages to using 3D printing, 3D printing of metals, because of the limits that we have with tools and things along that lines. Can you share a little bit about that, or what your thoughts are there on why why has it taken off so great for the aerospace industry, and
Yeah.
what do you think?
Yeah, like I said yesterday, I was at a company, a foundry in Franklin, Indiana. It's like 20, 30 minutes south of Indianapolis. The company's called ICT. So if you remember back, I can't remember exactly, 5, 10 years at most, there was an impeller on an airplane and it came off the engine and it went through the cockpit and it caused the crash or caused a problem, a fatality maybe, I think. Well, to make that impeller component, they were actually having people hand weld these things. And when you fabricate that, there are a lot of times where the weld isn't nearly as good or there's a problem, there's a crack. Well, what they were able to do at this company ICT by 3D printing that in metal was to take away all of that uh, manual labor, number one, but to use a super alloy that they couldn't use for welding for hands. You weren't allowed to use that super alloy to weld with. You could only pour with that, and then they found a way that they could actually 3D print with that super alloy. So it upped the game for them. That the strength of the material, the strength of the component went through the roof. The manufacturability stayed up because they just had 3D printers running. They have 5 3D printers, and they're all just running, right? Actually, when I was there yesterday, they had one that had 4 lasers on it. It was actually printing one of those impellers, I believe. So one of those components for their aircraft. And then the company can say with assurance, hey, you know what? And because by the way, they X-ray every component that goes out. I know the weld was good because I X-rayed every bit of it. It wasn't a guess. I created it with a super alloy, which takes the strength of the component way up compared to where it was with the lower alloys that were done by hand welding and fabrication. And then I X-rayed it to verify it. And here, aircraft company, here's my new impeller for you. And you can be assured. And then not only that, but then you can go to the public and say, what we have done as a company is went down a new path of discovery and found this new opportunity where we created a better component, safer for you, safer for us, and then now you want to fly with us. Right?
Perfect. And I know others kind of pointed out the ideas that, like this engine block image that we have in front of us. I know that you guys have some flash and some things where you got to get a tool in there and take out some of that, right? And so that's one of the benefits, they said, of the 3D printing, because there's all sorts of internal chambers and things in a lot of these jet engines that you can't get a tool path in. And
Yeah.
so I thought that was kind of a cool application, as that in the 3D printing world, the shape, we're not bound by the tool path type shape, if you will.
Yep. I was actually going to bring up a picture and I can't find it. I got an email today of Flash and how it was created, because when you when you put those sand components together, there's a little bit of a gap where you can't meet up perfectly. So where my knuckles come together, there's a little bit of a valley there. In that valley, they might say my fingers are the sand, and the valley is iron out right here in the middle. Well, that's always a fin that needs to be cleaned up because it's a stress riser as well. But if I 3D print, that's gone. That is no longer there because I
Yep.
filled it in, did it exactly the way that I wanted it. I didn't have to worry about gluing two pieces of sand together and pouring iron around them. So it makes it stronger from
Absolutely.
that perspective as well.
I think it's so awesome to see this technology really taking off and just seeing the applications. Because I think too many times we see that people are printing things off Thingiverse and stuff like that. We're not seeing like the real world application of this stuff. And so I've always appreciated you joining us and really kind of giving us that view from what it looks like in the manufacturing world.
Yeah, I apologize for not having those. I will send
No, it's
those as
fine.
pictures.
Because you can
have them.
send exactly. You can send them later. We'll put them on our channel. I think we do have to keep moving here. We're kind of up on our time. These teachers have some more work that they have to do this afternoon, so we want to let them get back to it. Any other final comments from anybody? Oh, there you go. There's your flash.
Yep.
Yep.
So this machined face right here wasn't a machined face. It was a cast surface like this. And see how rough that is? It came around here. But as a casting, as a foundry, I can't poke that flash because that hole isn't there until it gets machined. So I cast it, send it to the manufacturing machine shop. They mill this end off of this like loaf of bread. Say it's like a loaf of bread, and there's an end there, and you mill it off, and you slice into it. You're like, oh, look at all this flash. We can't have that. You got to clean it up. Well, now we have to pay the machine shop to clean it up, or we have to send the component back to the foundry, have them clean it up, send it back to the assembly shop, and with all that transportation back and forth, you're going to have a problem. You're going to have a ding. This is a really critical service to us. We don't want it dinged. Well, it might get dinged in the transportation process. So that flash in there is where the two pieces were welded together. And on this edge right here, that little fin, we don't want that little fuzzy fin there. Or this one right here.
That's great. I can see that really well, and I know if others can't see that well, if you click on the image, you can toggle between Steve being the main image on your view or his slide deck, and so you can toggle back and forth. I think many of you have been able to navigate that part. Fantastic. That's awesome to be able to see what we're talking about there. Anybody else? Final comments, thoughts, questions? I would assume we could email him some of those. I could help get the contact for him if you wanted him to be able to speak a little bit to your students. You know, the thing I like the most here, and I just I would end it with this, is I want to help somebody rewrite their story, just like Steve's situation, right? You know, he had people who believed in him. I love the fact that, and you always start your presentation this way, reminding teachers how valuable and important that they are. And I think we've heard that before. We hear it during, Teacher Appreciation Week, but every one of us had somebody in our life that believed in us or took time for us. And I love your story. And then I love the whole idea of rising up out, right? And so that's one of the reasons why I'm passionate about this project, because we're trying to go to places in the country where we know that there's great opportunity to help students see a future and press into that, right? And so it's just it's a good story, and if I'm going to take time to put forth the effort to do something like this, I want to be able to envision a young person just like yourself, Steve, that has somebody invest in them. And this could be, these lessons or the things that we're trying to do here could be just the opportunity for them to kind of rewrite their own story and, find a career pathway for them.
Yeah, absolutely. And I appreciate it, Don. Thank you. And also, there's a Caterpillar facility in almost every state in the country. So reach out to them, ask them, hey, can we tool your facility? You have to wear jeans and you have to wear closed-toed shoes. You're good to go. And you can walk your classes through there. And they'll have someone. We have a 1.5 million square foot facility here in Lafayette, Indiana that we could walk through. But there are throughout the country facilities for Caterpillar. And again, like Todd said, I'll send him my contact information, and if there are any questions for you, if you want to reach out to us or see postings or anything where I could help direct you to HR for your students or those that you're helping, I most certainly will.
Steve, thank you so much. I really appreciate your time, and I thank everybody for joining us. Thank you all for being flexible, and I'm so appreciative that we got this in.